right, so today what we're going to talk about is basically we're going to work our way through this entire packet. This is going to be kind of a crash course on algebra, or crash review of algebra. Normally, remember, I would have spread this out over today, tomorrow, Wednesday, with a review on Thursday, and then the quiz on Friday. But I'm making this podcast so you can go through and watch this again. This is going to be longer than our normal podcast. One thing you will notice about the podcast, once we get into Edpuzzle, is most of them are between 9 and 15 minutes. That's it. Because for an online class, you'd have to kind of condense the teaching down to what's essential. Like I said, don't be afraid to use that pause button. The packet I handed out on Friday. If you don't have it, everyone got one, so if you don't have it, it is online. You'll have to print it out and take it that way. I do not have extras. Okay? Probably. Don't forget to take it home. You will need it. But if not, all those sheets are actually already scanned and uploaded to Schoology. So if you forget it, if you lose it, if something goes wrong, it's there. So what we're working on is polynomial and quadratic equations, both multiplying and factoring. So putting them together and taking them apart. And today is just going to be a real quick review of that. We're going to try to hit almost all the possibilities, but I probably will miss a couple, but that's where the office hours come in, and you can ask questions on that. Just a note, the office hours do begin on Thursday, not tomorrow and Wednesday, because I will still be in here working on other stuff tomorrow and Wednesday. But you may always, at any time, email me a question. All right? And I may say, okay, I'll open up, and if I have to explain it, if I can't do it real well in an email, I may respond, could you be available for a quick conference at this time, and then we can go into Schoology and we can conference through it at that time. So, but if you email me at like 1 in the morning, I'm going to be sleeping, so you have to wait. All right. Basically, the idea here is we're trying to put together and take apart polynomial equations. And we're used to solving equations and doing things like distributive property. You know, I get things like 2 times x minus x plus 7. Okay? And we know how to do that. That's just 2x plus 14. And that's what we're going to start doing, is really simple stuff. Now, when we get 2 binomials, like this, it's still just distributive property, but we have to distribute everything with everything else. So the acronym we use for that is what? FOIL. Stands for first, outside, inside, and last. Okay? Literally what that means is I multiply the first numbers together. N times 2n gives me 2n squared. The outside numbers, negative 5n. The inside, plus 6n. And the last, negative 15. Then we combine any like terms. Usually outside, inside are my like terms. Okay? Usually outside, inside are my like terms, so that's 2n squared plus 1n minus 15. Okay? And that's FOIL. Now, are there possible times where the outside, inside won't combine? Sure, that can happen. But if there are like terms, you should combine them and simplify them. It's pretty straightforward. Sometimes FOIL looks a little different. Sometimes we have things like this. Okay, 5n minus 2 squared. The thing you have to be careful of here is that we don't just distribute the exponent. We can't do that with a polynomial like that. We have to remember that this means 5n minus 2 times 5n minus 2. And then FOIL. So 5n times 5n is 25n squared. Outside is negative 10n. Inside is another negative 10n. And last is a plus 4. So obviously we have to be very careful with our signs here, doing this algebra. We got to watch if we're multiplying a negative times a negative or a negative times a positive. And 25n squared minus 20n plus 4. Simplify. Okay? So that's the way that kind of works. And a lot of our first half of the first day is just that multiplying. The multiplying is actually the simplest part. The second part of the first worksheet is called extracting roots. And extracting roots happens when we have equations that have an x squared in them, but not just an x. So if I have, say, n squared minus 5n equals 14. And I'm sorry, n squared minus 5. Let me get the right example here. 3x squared minus 7 equals 18 plus 2x squared. Okay? If I have equations that just have an x squared in them, but not an x, so just an x squared, not an x, that's actually pretty straightforward. We just solve it like we would normally. Bring the x's to one side and the constants to another side. And I get x squared equals 25. So x is the square root of 25, which is positive or negative 5. There are two solutions. One is positive 5, one is negative 5. Why? Because negative 5 squared is 25, just like positive 5 squared is 25. So we're going to have equations like that. Or it just might be something even simpler like n squared equals 30. And again, we know how to do that. N equals plus or minus the square root of 30, which I could simplify if it does. Square root of 30 actually doesn't simplify. So keep it simple with that stuff. What gets much more interesting is when we put a trinomial together. And now we're getting actually into like day 4 or day 3. We're skipping day 2 for a moment. We're going to come back to it. But we're jumping into day 3. What happens when I get something like this, like a trinomial? So trinomial means I have 3 different terms that I can't combine. I have an n squared term, I have an n term, and I have a constant. Nothing cancels out, nothing goes away. How do we solve that situation? Well, the way we solve a trinomial is to bring everything to one side of the equation and set it equal to 0. See, what I want to do is this. I want to figure out what values of n make this true. And if you recall from algebra, what we do is we factor the polynomial. Now, whenever I multiply things two things together, and the product is 0, that means one of those two things must equal 0, or both of them possibly. But at least one of them must be 0. I can't multiply two non-zero numbers together and get a 0 answer. That's a zero product property of algebra. That's why we set it equal to 0, because I can multiply a whole bunch of the infinite number of things together to get to 14. There's an infinite number of combinations that get me 14. People say, no, it's just 1 and 14 and 2 and 7. You're ignoring the fact that there are decimals, radicals, square roots, all sorts of different ways I could get to 14. Fractions. There's an infinite number of ways I could multiply to get to 14. However, multiplying to get to 0, one of them must be 0. That's why we want to set everything to one side. And then we have to factor this polynomial. Now, if you recall the process of factoring, what we do factoring is we look at a couple different things in the polynomial. The first thing I do is I look at this number here, negative 14. That's going to be my product. And the coefficient of the middle term, that's my sum. So I need to find my two magic numbers that multiply, give me a product of negative 14, but add to give me negative 5. Now, there are a couple of hints. If the product is negative, that means one number is positive and one number is negative. It has to be to get a negative product. If it's positive, they're either both positive or both negative. Since the product is negative, it means they have different signs. Since the sum is negative, it means that the bigger number has to be the negative one. So what are two numbers? We have a pretty limited number of choices to get to 14. And again, we're only looking here at integer. It's not like we are looking at the infinite number of solutions. We only want the integer solutions. So what two whole numbers multiplied together give me 14 and add to give me 7? Yeah. 2 and 7 are 1 and 14, right? And this time, in this case, it's going to be what for signs? We got to pay attention to signs. Well, negative 2, 7 will give me negative 14, but give me positive 5. So 2, negative 7, right? The negative has to be the 7. So my magic numbers in this case are 2 and negative 7, because that gives me that product and that sum. So positive 2 and negative 7 and n and n. Okay? Those are my magic numbers. Now, that's the factoring of it. I still need to solve it. What number would I put in here that would turn this into a 0? Because this needs to be a 0. What value could I put in for n to make this 0? Negative 2. How about here to make this one a 0? Positive 7. So my actual solutions for this equation are negative 2 and 7, which means if I put negative 2 in here, negative 2 squared minus 5 times negative 2 equals 14. Well, 4 plus 10 is, yep, that works. How about 7? 49 minus 35 is 40. Yep. By goodness, it actually works. I've actually found my solutions. So what we're going to focus on for the next little bit as we're talking through here, or for the remainder of the hour today, is this idea of factoring and how do we factor polynomials? Because that's obviously a very important part of the process. So let's practice some factoring. Okay? Now we're kind of on to tomorrow's lesson, which is factoring without solving. So tomorrow we aren't going to be set equal to 0 yet. We're just going to be factoring. So we're going to see problems like this. P squared plus 8p plus 15. Okay, let's factor it. My product has to be 15. My sum has to be 8, positive 8. What two numbers multiply to give me 15 and add to give me an 8? 5 and 3 are my magic numbers. So this very simply factors into p plus 5, p minus, or p plus 3. Now, some people say, which one goes first? It doesn't matter. You can do p plus 3, p plus 5, p plus 5, p plus 3. It doesn't matter. Okay? And if I multiply the FOIL that back out, I'd wind up back up there. So we're basically taking that FOIL apart again. It's backwards FOIL. You remember doing this in algebra last year. You spent a lot of time on this in algebra last year, right? It is a pretty essential skill, too, for Algebra 2. We're heading into that direction next year. Intermediate algebra spends literally weeks doing this. All right, let's try this one. Plus 3x minus 40. Okay. Let's factor this one. My product has to be negative 40. My sum has to be positive 3. So I need two numbers multiplied to give me negative 40 and add to give me positive 3. Now, some people are really good at picking these numbers out of their head fast. Some people have to be a little more systematic about it. So let's go through the systematic process just for those individuals right now. Multiply to give me 40. Well, that's 1 and 40. Well, that's not going to give me a 3. So that could be 2 and 20. And remember, now one of these is going to have to be negative because it's negative 40. In fact, the smaller one's going to have to be negative. So we'll go there. That gives me an 18, not a 3. 3 doesn't go into 40. 4 and 10. Well, that gives me a 6. Pretty closer to 3. 5 and 8. Aha! That gives me a 3. So if you're stuck, just start writing down your numbers that multiply to give you 40. Start with 1, 2, 3, 4, 5. Find the partner that goes with it until you find the pair that gives you your magic numbers. My magic numbers here are negative 5 and 8. So this literally factors into x minus 5, x plus 8. Done. If you're not sure, check your answer by FOILing it back out and see if it works. Okay? That's basic factoring. There's some special factoring. One of the special factoring problems we get is called difference of perfect squares. Things like n squared minus 25. In essence, what this means is n squared plus 0n minus 25. So my product is negative 25 and my sum is 0. What two numbers multiply to give me negative 25 and add to give me 0? Negative 5 and positive 5, right? N plus 5 and minus 5. It's called difference of perfect squares factoring. Okay, it's a pattern. If you remember it, it makes your life easier. It simply says that a squared minus b squared always factors into a plus b, a minus b. And you can remember it as a pattern, or you can just put that middle term back in there as a 0 when you have to factor it. What you really shouldn't forget is that there's always still a possibility that your factoring is going to be even simpler. It might just be greatest common factor. Factor that. Well, it's not a constant, so I could just take out the n. It's a distributive property backwards. That's it. And I'm left with n minus 3. So sometimes my factoring really just comes down to greatest common factor. And that's all there is to it. So factoring can be fairly simple. And when the number in front here is a 1, when the first number is a 1, when there's not a number in front of the x squared, factoring is quite simple. Factoring gets more complicated when we put a number in front of the x squared term. Let's look at this one. Okay. Now it's a little more complicated. As soon as we throw a number in front here, a leading coefficient we call that, as long as we throw a number in there that's not just a 1, factoring becomes more complicated. So what we want to do is we use what's called the AC method. It's called the AC method because the general form of a polynomial equation like this, a quadratic equation, is ax squared plus bx plus c. A is the number that goes to the x squared, b is the number that goes to the x, c is the constant. And so now our product for our factoring, finding our magic numbers, we're still going to find magic numbers. But our product is whatever a times c is. In this case, that is 3 times 5, which is 15. My sum is still just b. Now, this actually holds when there's the 1 in front of here, too. It's just that 1 times c is just c. Okay? This technique holds. It's just not necessary when there's a 1 in front. So my sum is still b, and in this case, my b is 16. So I need to find two numbers that multiply to give me 15 and add to give me 16. 1 and 15, yeah. A lot of people struggle with that one because it's the most obvious one. It's the easiest one, but some people don't see the most obvious answer. That 1 times 15 is 15. Okay? So my magic numbers are 1 and 15. But when I have that leading coefficient in front, I can't just say p plus 1, p plus 15. Because if I FOIL it back out, I wouldn't get 3p squared, would I? So what we do with our magic numbers now, and this is the nifty part, but also the kind of complicated part, is I'm going to use this plus 1 and plus 15 to break up this middle term into two terms. I'm going to turn that into a plus 1x and a plus 15x. Now, all I'm doing is re-expressing it, right? There's still 16 x's there, just like there were before. I just split it up. And the magic numbers tell me exactly the right way to split it up. I mean, I could do 2 and 14, I could do 3 and 13, I could do any number, any different way of getting to 16, right? I could do 17 and negative 1. But the magic numbers tell me exactly the right way to do it. So we're just re-expressing that middle term, and then we're going to bring down my other terms. My 3x squared is still there, and my 5. Who remembers what we do now? Now I've got a 4-term polynomial. What do? We group them. We group them. We put in parentheses. That should be a plus. I forgot my plus sign there. Oh, I lost it. That's the reason. Plus 5. Okay? We group them. First two to go together, last two go together. The sign in the middle does not get grouped with anything. If it happens to be a minus sign, I have to change the sign in this grouping. We'll see an example like that in a little bit. Okay? Then I do greatest common factor just with this. What's the greatest common factor for just these two terms? Greatest common factor is just an x. I'm left with 3x plus 1. Plus, bring the plus sign down, what's the greatest common factor between 15x and 5? 5. And I'm left with a 3x plus 1. If these two don't match, you've done something wrong. But they do match, so I have a greatest common factor now of 3x plus 1, and I'm left with an x plus 5. And I have factored that polynomial. I've undone the FOIL that gave me this. Now, I know it's been a while since you've done that, but you have done that before. Quite a bit. So when you start practicing it, hopefully it's going to start coming back to you. But again, these are the types of problems that you may come in, drop into office hours and say, hey, number 17, and I'll say, what was the equation? And we'll work our way through it. Okay? So that's the way that works. Now, what if instead of this, it was an equation? Actually, it really doesn't change anything. We still do the factoring process the same. Just that once we get it all solved out, now we can write down what our solutions are going to be. What number would make this a 0? Negative 5? What number would make this a 0? Well, we could do a little mini problem. Aha, negative 1/3. Or what most people do is recognize that if you have the factors, it's the opposite of the constant divided by the coefficient. Negative 1/3. Okay? Or you could do the mini problem to get that. So those are the more complicated ones. Let's do a couple more. Sometimes the problems for solving, yeah, if you have to. Sometimes the problems for solving are pretty easy when it says solve by factoring. Some of the problems in the worksheet are fairly straightforward. They're already factored for you. 2n plus 5 times 4n minus 7 equals 0. There's nothing left to factor there. It's already factored. They just want us to solve it. How do we solve that? Again, we could do mini problems, or I could just take the opposite of this, negative 5, divided by this. And opposite of negative 7 is positive 7 over 4. Those are my solutions. Okay? Or, like I say, you could do the mini problems. You could say 2n plus 5 equals 0, 4n minus 7 equals 0. So 4n equals 7, so n equals 7/4, minus 5, 2n equals negative 5, n equals negative 5/2. You could find the pattern, or you could do the mini problem. It doesn't matter. They're both pretty straightforward. If you know the pattern, it's a little faster. Some of the problems will be more complicated. Sorry. What's the difficulty here? It's not equal to what? 0. So how do we make it equal to 0? Add 5 to each side. So m squared minus 11m plus 30 equals 0. Is this going to be a nice factoring problem or a hard factoring problem? Nice. Why is it a nice one? Yeah, there's not a number in front of the m squared. Okay? So this one we look at, we see that the m squared does not have a coefficient, so this is going to be a super nice one. I just need to find my magic numbers. My product has to be 30, and my sum has to be negative 11. Now, the fact that it's a positive product tells me that both numbers have the same sign. They're both positive or both negative. The fact that the sum is negative tells me both numbers have to be negative. I can't add two positive numbers together and get a negative. What numbers would those be? Negative 5 and negative 6. So my magic numbers are negative 5 and negative 6. So this factors into m minus 5, m minus 6 equals 0. And my solutions are the opposite of my magic numbers when it's a nice one. Those are my actual solutions. Now remember, worksheet 2, day 2, you don't actually have the equal to 0. You're just factoring, and the factoring is your solution. Day 3 is when we have to write out, take it to the next level. Okay? How about this one? Here's one that's a little more complicated. 4x squared minus 2x minus 4, or plus 14. Final example. Equals 26 minus 2x squared minus 3x. Final example. What are we going to do? Tuck our head between our legs and cry? Pray we get the virus, and rather than having to deal with this, because that'd be better? No. We're going to bring everything to one side. Okay? Do minus 26 plus 2x plus 2x squared, sorry. Wow, don't do that mistake. Plus 3x. Okay. I'm left with 6x squared plus x minus 12 equals 0. All right. This is not going to be a nice one. This is going to be one of the AC method ones. That's okay. We can do it. Product has to be 6 times negative 12, which is negative 72. My sum has to be 1, 1x. So what two numbers multiply to give me a negative 72 and add to give me a 1? No, that wouldn't give me an add to 1. 8 and 9. Which one would have to be the negative one? The 8, right? The smaller one, because the 9 has. So 8, negative 8 and 9 are my magic numbers, right? Negative 8 times 9 gives me negative 72. Negative 8 plus 9 is 1. This is where knowing your times table is like super critical. If you just rely on a calculator to multiply 8 times 9, that's going to make this super hard now. What are we going to do with those magic numbers? We're going to use those to split up this middle term. 9x or plus 9x. I'm sorry, let's do the negative one first. If you have a choice, always do the negative one first. Minus 8x plus 9x. I just split that up. Still just 1x, but I still have 6x squared minus 12 equals 0. Now we're going to group. What's the common factor here? 2 goes into both of those and x. So I can take a 2x out and left with 3x minus 4. What goes into here? 3. And I'm left with 3x minus 4. And the common now is 3x minus 4. And I have a 2x plus 3 remaining. So, almost done. X equals 4/3 and negative 3/2. All right, good luck. Hope to see you again this year.